Hi, this is Pradyumna Pathak, and today I would like to demonstrate to you my code implementation of my novel approach that I'm working with Dr. Jamshid Sarati for extracting mathematical embedding using LLMs of a single word such that the context is maintained. So I would like to have this demonstration in two parts. Part one is I'm going to be going over the theoretical idea of what this approach is. And then in the second part, I would be showing you the code that I wrote to implement this theoretical approach. So the approach is called hierarchical context embedding. The reason it's called that is because we hierarchically create like a tree, and the tree has nodes where each node is a definition of a keyword. And these nodes are connected based on how those keywords are related to each other in any field of science. So uh, starting with part one, which is a theoretical explanation. Let's say that we have a word charge, and our objective is to get a single mathematical embedding of this word. Uh, to get First step of this approach is that we need to create something called as a context tree. A context tree is created using an LLM, and you give the word to the LLM along with the prompt, and you ask the LLM to describe the word. And the LLM gives you a description, and in that description, it is told to highlight any other sub keywords that are related to this initial keyword. So in this case, it would be subatomic particles and electromagnetic interactions. So then again, we repeat the same process for each of these keywords, giving us a new node. And then that's how the tree kind of expands. So this forms a tree of sentences where sentences are defining a keyword, and that keyword is present in an initial sentence in a level above. So that's step one. Step two is we take these sentences and we uh, basically calculate embeddings of the word that is present in that sentence. So in this case, it would be charge. So charge has subatomic particles and electromagnetic interactions. So we get the embeddings of those words, and then so on and so on. We just keep going down the tree. We start collecting embeddings, and then we multiply them with their uh, depth at which those keywords are present in the tree, which is called the weighted average. And then we take the weighted average of all of these embeddings, and then that's how we get the final embedding. So this is the hierarchical approach. Now on to the second part of the video, which is code demonstration. Again, I have implemented the two steps where step one happens in this script, which is called the context tree builder. It builds the context tree that we talked about. And then this one is the one that calculates the embeddings of each word in that tree at every node. So the way it works is I have kind of neatly put it together in this main script. This main script is reading a text file which has medical drug names. Those are our subject, like those are our examples. So we start with a keyword, which is the drug name, and then we pass it down to this class. And what this class does is it calls the context tree script first because we have to build the context tree first. So the way it initializes it is it's using the Phi 3.5 LLM, which is a Microsoft provided model from Hugging Face. And I'm starting with some initial temperature values and giving it a token length. And this is the prompt that I was talking about. So I've told it that the model is a GPT model that is, you will be given with a keyword. You have to describe the keyword in terms of other sub keywords, so on and so forth. And then basically what I'm doing is for processing it, I'm just doing a breadth first search. So I start with a keyword, I give the prompt, I get a definition, I get the keywords from that definition. So this is where you get the new keywords. And then I just add that new keyword to my queue. Uh, and then as you can see, we will add the child nodes to the queue over here. So it's basically a simple DFS, but at each node, we're running the LLM with this prompt, this initial prompt, and we're placing our keyword over here, and we're giving it the idea of describing it. So that's step one. What this does is it creates a JSON file, which is the tree itself. So as you can see, we have the depth of every node, And so this node has depth one, which is the root node, and then it has children, which is the sub keywords that is present in this definition. So this is how you get like a tree, and I've stored the tree as a JSON file. That's step one again. Step two is we have to convert these sentences into numbers, into our embedding vectors. The way that happens is, so this is again the main script. In the main script, once the context tree is done executing, we call the hierarchical embedding class, which is in the second script. Now, what this does is it traverses this file, this JSON files. It's basically simple tree traversal, and it's what it's doing here is it's loading the file right over here, I believe. Create embeddings. Yeah, so it loads the file and then it processes it in this method. What this method does is it's reading the file, which has the keyword and its response, which was given from the LLM, and then it's calling this function. What this function does is it uses the BERT Cybert model here to get tokenizing it and then giving us the embeddings. And these embeddings are then uh, stored in a similar tree structure in this process tree function. And then we are giving it the weight coefficient according to this example that I showed you, like the weight is the depth. So as you can see, the weight is, we're just fetching the depth data from that JSON object, and we're just multiplying it in a weighted average form. And then we just multiply this weight coefficient with the vector embedding itself. So it might be too complicated here, but basically what this two line of code is doing this part, the weighted average, like this part. So this is how I'm converting a single word into a tree. So that tree gives it a context, and then each definition is converted into its own vectors, and then those vectors are kind of like done. We do weighted average of those to get a final embedding. So that is about my code review. Thank you so much.